Now to continue on to how we might identify the variability with respect to yield or soil characteristics that we have found from using locational information. This is a yield map of wheat, albeit a little fuzzy. The colours show us different yields over the area of the paddock. We used GPS to determine where the yields occur. What GPS doesn't tell us is why we are seeing this variability. This second presentation will address the second learning outcome and teach you how ethically and scientifically sound experimental science can be used to identify variability. In particular, this week's lecture will cover the scientific method, ethical science including data collection and presentation, and how to write a scientific report. The scientific method begins with asking a question. In this example, that might be, why are there yield differences across the paddock? Or we could be more specific and ask, what is causing the low yields in the paddock? Step is to do some background research by getting in and looking at the paddock and looking at our site, by reading, talking to others, or looking up information on the internet. What clues can we find that we can identify the most likely reasons that could apply to our situation and location? You might find that there are several possible causes that could be causing the differences in yield. To use a scientific method, we look at, in isolation, each possible reason that could be responsible for the observed variation. Choose the most likely cause first, and then state your hypothesis. The hypothesis is not a question. It is a firm statement that identifies one factor that you believe is causing the variation. H0 denotes the null hypothesis, and the null hypothesis always states that the factor you are testing will not be the cause of the variation. That is, when you conduct your experiment using a scientific method, the null hypothesis will be that there will be no difference between treatments. In this example, the difference in yield is suggested to be because of low soil pH. Therefore, the null hypothesis states that there is not any differences in yield due to low soil pH. The purpose of the scientific method is to disprove the null hypothesis, and by proving that HA, the alternative hypothesis, is in fact correct. The alternative hypothesis states that there is an effect due to the variable being tested. Therefore, in this example, HA states that there is a difference in yield due to low soil pH. Step is to design an experiment to test your hypothesis. The experiment should minimize all external variables so that you can be sure that your results are determined only by the cause being investigated. In this example, we want to test if low soil pH is the cause for our observed variation in yield. Typically, this would be conducted in a controlled pot experiment where we take soil from the low-yielding areas and put it in pots. Then we would add lime to half the pots to increase the soil pH to a more favourable level for plant growth and grow our crop seeds in all of the pots. We only add lime to half of the pots because to prove our hypothesis, we need to see that adding lime is what makes the difference to yield. Yes, we could call in an agronomist and have our whole paddock soil pH tested, but what I'm trying to do here is to illustrate a simple application of the scientific method using a scenario that is not too unfamiliar to you. So let's see where it goes. When conducting an experiment, we need to ensure that the procedure is working and troubleshoot any factors that might cause the experiment to fail or bias their results. So it is important to plan and document also the steps of our experiment. For example, in this experiment, all pots would need equal access to light and to receive the same amount of water on a regular basis. When the experimental procedure is completed and we are confident that it has been conducted properly, then we can collect and analyse the data and from there draw our conclusions. In this case, we grew our crop in pots using soil from low-yielding areas in our paddock. We added lime to half the pots. We ensured adequate sunlight and water in equal amounts to all pots to encourage plant growth. Then we measured the plant yield from each pot, making note of which observations belong to the soil with lime group and the soil without lime group. In scientific terms, the soil without lime group is referred to as the control group. The soil with lime is our treatment, because that is the part that we are changing. To determine if our hypothesis H0 is correct, we then compare the results of the treatments and the control groups. If there is no difference in crop yield between the treatments and the control group, we would agree that the null hypothesis is correct. That is, that the difference in yield seen on our map is not due to low soil pH. This does not mean the experiment has failed. To agree or disagree with the null hypothesis are both valid conclusions, as they both give a useful answer. If the results had disagreed with H0 and in turn supported HA, that is, the difference in yield is due to low soil pH, we could have gone back to the paddock with the lime truck. However, by the results being in agreement with H0 or H0, we know that the lime truck would not have been the answer to the low yield problem. Hence, by agreeing with H0, we have confirmed that the low soil pH is not the problem, and we can cross it off the list of possible causes and investigate the next option with a new null hypothesis, such as the difference in yield is due to low nitrogen levels. The final step is to communicate the results. As scientists, we use the scientific report format to communicate our experiments, what we have done, how we did it, and what we found out. We will discuss how to write a scientific report later in today's lecture. So in summary, we have learnt how GPS technology is used to locate variability in our agricultural systems. The scientific method helps to identify why the variability may be occurring. We need to know what is causing our variability if we are to address the problem. The next part of today's lecture will look at how reasoning and logic is applied in the scientific method and the world at large.